Okay, another exciting video for you. I don't know if you like this better than me in front of the room or not, but we'll give it a try for a little bit longer. So here we have another aspect of translating, and we're specifically just talking about lines because translating lines is kind of funky. It's very interesting, and some weird things happen when you translate lines. Hopefully you've already watched the introduction to, or read the article on Khan Academy about introduction to translations, because that's going to give you good background knowledge. Plus the other lessons that we've done, you should be have a good understanding of what a translation is at this point. Remember, we're just moving a plane, sliding a plane from one point to another, or from one along a vector, in a certain direction along a vector. So today you're going to learn that when lines are translated, they're either parallel to the given line or they coincide. That means they're the same line, they go with it. Students learn that translations map parallel lines to parallel lines. That's crazy. So if you have parallel lines and you translate them, they're gonna be parallel. So let's look at a few exercises. We're going to do this with a teacher, or you can do it with a partner. You can watch me, or you can do it with a partner. So it says, draw a line passing through point P, this is P, that is parallel to the line L. Draw a second line passing through point P that is parallel to line L, and that is distinct, different from the first one. What do you notice? So let's see what we can do. I'm going to try to draw a line. I'm going to do ink to shape. I'm going to draw this line that goes through P. And let's see what happens. Oh, it didn't give me a shape. Sorry. Can I insert a shape? Can't do that. Draw. All right, well, we're going to have to say that's parallel. When you do this, please, I'm going to erase that because I don't like it. Please use a ruler. The rulers are outside of the room. I can't use a ruler on my iPad. You'd think I'd be able to draw a straight line, but it doesn't seem like I can. Anyway, so there's a parallel line to line L. That's line L. Draw a second line passing through point P that is parallel to L. So I'm going to use a different color. I'm going to use this purple. If I draw another line through point P that is parallel, what do I notice? Well, they're the same line. It's the same line. They coincide, right? They coincide. I can't draw two different lines that pass through point P that are parallel to L. That is kind of crazy. And that's what we learn about translations. If I translate this line, L, through point P, I can only do it once. I can't do multiple translations. It's going to be the same line. Now it says translate L along the vector AB. What do you notice? Well, here's line L. I want to move it along AB. So I'm going to make a copy of this, and I'm going to move it this way. And what I notice is it coincides. It's not a different line. It's, lines go on and on forever in both directions. So this is the same line as long as the vector goes along the line. Okay? Line L down here is parallel to vector B. Translate line L along vector B. What do you notice? So what I want to do is I want to take this little part and make a copy of it. Oh, sorry about that. So I'm going to take line L again. Let me use my blue color. All right, I'm going to take my blue color. This is my line L. And I'm going to copy my vector AB so you can see it. There's my vector AB. I like that thickness better. Should use that. And now I'm going to move mine along AB. If I move it that way, oh, where'd you go? There it is. L, let me use this color here. If I translate it along the vector, it becomes the same line. or they coincide. They're together. So hopefully you're saying that if I'm moving along the line along a vector, that those lines will coincide. Okay? Now it says translate line L along the vector AB. What do you notice about L? Well, let me take L. I'm going to copy it. I like this color. There's L. And I want to translate it along AB. So I'm going to take that, lasso it. And I'm going to move it along AB, translate it straight up. What do I notice between these two? Something pretty cool. These become parallel lines. Pretty awesome. Pretty awesome. Now here it says the line L has been translated along vector AB. So it went from here to there. And remember, correct notation, these are all L primes. Let me do that. This would be L prime, and this would be L prime. All right, sorry about that, I forgot. So I have L and L prime here. What do you notice about the lines? These lines are parallel. And then I'm going to stop there because I think now you can, let's do one more together because this one's fun. We have L1 and L2. These are parallel. L1, L2 parallel. And I have my vector DE here. This is my vector. And I want to translate L1 and L2 along that vector. So I'm going to slide it along that vector. Well, what do I notice? This is crazy. I'm going to label these L1 prime, L2 prime. These two are parallel, just like these are parallel. So if I translate parallel lines, then they stay parallel. Parallel lines will stay parallel. All right? Pretty cool stuff. And with this, you can do a lot of interesting geometric proofs. And you'll notice a lot of this in nature, and you'll notice a lot of it in architecture. This translating of lines, super important. And just very, very interesting. All right. So the lesson summary, we have two lines in the plane are parallel if they do not intersect. Translations map parallel lines to parallel lines. Given a line L and a point P not lying on L, there's at most one line passing through P and parallel to L. And that's it. And now go ahead and work on your problem set.